So in last few classes, we have seen basically RAG, and today also we will continue with that only. Uh, so in RAG, so one thing that we have seen is a cosine similarity. Okay, and in LangChain also. So if we see like vectors uh, store dot with similarity, okay, we mean the name can be different, but the idea is like anything that we see similarity, it is basically representing by default cosine similarity. Okay, cosine similarity. So when we ask anything, um, or so let's say there is a quiz, basically query, and when this query happen, so it will try to search from the vector store and give the relevant documents. Okay, so today we will see one more thing that is called MMR. Okay, MMR. So the full form is maximum marginal relevance. Okay, so this is built on top of cosine similarity. Um, so there is slight variation in the output. So the problem, first let's see what is the problem with cosine similarity and why we required a MMR. Okay, so problem with cosine similarity, and in short form we also the similarity search. Similarity search. So when we do the cosine similarity, uh, let's say if you ask something like uh, maybe there is a some document and you are asking what is the highest score of MS Dhoni. Okay, let's say we have ingested or stored some document in vector DB about MS Dhoni. Okay, so and let's say we have basically store multiple documents related to highest score or about MS Dhoni, and let's say we fix k equal to 5. So k equal to 5 means it will provide 5 similar document based on the user query. So this blue color thing is a user query. Just a second. Uh, So this blue color thing is a what is the highest score of MS Dhoni? That is a basically a query, right? And if we fix k equal to 5, so it will provide the 5 relevant document that is from the vector store. Okay. Now let's say the answer is the highest score of MS Dhoni is 183. Okay. Let's say it pick other chunk and there also the similar thing is present. Okay. The highest score of MS Dhoni in ODI is 183. Okay, there is slight variation, right? Means only the highest score of MS Dhoni is 183, highest score of MS Dhoni ODI is 183. Similarly, let's say there are 2-3 more documents which are similar or may not be similar. Let's say the highest score in test is I don't know the number, but let's say 224. Okay, फिर the highest score. Someone audio can someone Okay, you guys, can you mute yourself? Your voice is coming. You are not on mute. Okay. So the highest score in IPL is, let's say, 57. Okay. So total four document. Okay, let's say one more document. Uh, the highest run in ODI is 183. Okay. So if you see, there are, let's say, total five result. Okay. Uh, so there are total five result. Three, four, and five. Okay. If you see, uh, the f- the first one, the second one, and the last one is quite similar, right? The highest score of MS Dhoni is 183. The second output is the highest score of MS Dhoni in ODI is 183. And the last one, the highest run in ODI is 183. So these are quite similar document, right? And the fourth and okay, so the third and fourth, the highest score in test is 224. The highest score in IPL is 57. Okay. Let's say if I do not want the redundant thing. Redundant means I do not want repetitive output. Okay. But if you see here, the first one and first, second, and fifth one is almost repetitive thing. Okay. So this is the problem with cosine similarity or similarity search, that it give you the output which are redundant. Okay. Means it will pick from the vector search only, but let's say in vector means when you store document, there may be a multiple copy of the same thing, right? uh, and there will be slide variation in it. So uh, it tries to pick the, based on cosine similarity, it try to pick the, based on user query, it will try to give you the similar output. But in that also, we do not want redundant thing. We want similar thing, but not a redundant thing. So if I put k equal to 5, I do not want the same copy of the, let's say 1, 2, and 5 are almost a same copy, right? So instead of 3, I just want one of them. The highest score of MS Dhoni is in ODI is 183. That we want. So this is the problem with cosine similarity. So MMR basically, MMR try to remove the redundancy. Okay, try to remove the redundancy in the similarity search output. Okay, so if I, let's say in the same thing, if I apply MMR and let's say, uh, so what it will do from the all five, let's say if we have D1 to D5. Okay, so what it will do, it will pick the things which are uh, uh, from this five only, it will try to pick the things which are not similar. Okay, for example, it will provide you the output, the highest score of MS Dhoni is 183. So this is the one output that it will give. The second output, it will the highest run in IPL is 57. Third, it will provide the highest score in test match is 224. Okay, so it will provide the output which are not similar. Okay, and this will basically help uh, uh, means it not losing the context. You are asking what is the highest score in highest score of MS Dhoni. So it will provide three answer. Okay, uh, here, and all these three answer are relevant yet different, right? So MMR basically help you to get the relevant answer without redundant redundancy. Okay, so it will not provide you the same copy of the output. Means the output will be different. Each output will be different. Uh, the similarity between the output will be very less. Okay, and that you can control as well. So if you see the formula of MMR, so there is a formula to basically calculate MMR. So MMR of DI, so D first let's see. So there is a lambda parameter. So lambda into similarity of DI comma Q. I will tell what is DI, what is Q, but minus 1 minus lambda. Okay, then max of uh, di comma dz or document already selected. Okay, yeah. So this is the formula. So lambda into sim means okay. Now let me tell what are the. So lambda is a controllable parameter. Controllable parameter means its value you can decide, and its value lies between 0 to 1. Okay, so it can be 0, 0 0.5, 0 0.1, any value between 0 to 1. Okay, then sim. Sim is basically similarity, the cosine similarity. Okay, similarity, you can say cosine similarity. Okay, uh, then okay, Q is query. Query means what user is asking. So that is a query. Okay. Next thing is uh, DI. DI is basically ith document. Okay. And then uh, there is a called document already selected. So maybe I can put that as a DS. Okay. Document already selected. Okay. Yeah. So if again I write the formula, so MMR of DI will be so lambda into similarity of DI comma Q minus 1 minus lambda max of here similarity DI comma DS. Okay, so this is the formula of MMR. Okay, you don't have to remember the formula, just how this formula is working, that we need to understand. Okay, so let's see it through some example. Okay, so I've already created one example. So here also instead of ds, here dz is written, but do not worry about that. So let's say and this MMR step. So first you do the let's say you load the document, you do the chunking, you create the embedding, store in a vector DB. After that only we do the cosine similarity and right means for retrieval we do the cosine similarity, or here I am talking about MMR, right? So let's see some example. So here, uh, let's say user is asking cause of global warming, and I basically let's say I have created one document about global warming and do the vector embedding, storing in a vector database that is already there. And here, let's say the lambda value is 0.7. Okay, lambda value is 0.7, and user has asked cause of global warming, and with the help of similarity, cosine similarity, it give me the 5 document. Okay, or the 5 output. So the first output is CO2 emission from vehicles. Second, industrial carbon emission, deforestation and forest. So these 5 document that with the help of cosine similarity. Okay. Here, if you see the right means sim of di comma q, it is just a cosine similarity score. Okay. So the highest score is for D1. Okay. So this is the most relevant document based on the cause of global warming. Okay. And similarly for D2, D3, D4, D5. So it is just a cosine similarity between the document and what user is asking. Okay. So which has the highest similarity score? D1. Okay. So this is with the help of, so this part is sim of di comma q is calculated. Okay. Now next part is, let's say the di comma dz. Di comma dz means you have to find the similarity score between D1, D2, D1, D3, D1, D4, D1, D5, similarly D2, D3, all the possible combination. So the possible combination is D1, D2, D1, D3. So these are multiple possible combination, and they try to find the similarity score between them. Okay. So if you see here, this part is there. Okay. This part gets calculated here. And here, let's say we put lambda equal to 0.7. Okay, lambda equal to 0.7. So this part we have calculated similarity of di comma q. This part is also calculated similarity of di comma dz. Lambda value is also uh, provided. Now the if you see the MMR of di, okay, so di I vary from 1 to 5. Okay, so let's how MMR is calculated. Okay, so first let's say step 1, initialization. So first we create a empty set, and in this document D1 to D5, first we select the most means the document which has a highest similarity score. Okay, so which is the document 0.95. Okay, CO2 emission, that is the highest score. Okay, now just, uh, so this document has a highest similarity score D1. Okay. Now here the first step was pick the highest score document. So highest score document was D1. Now in step 2, try to find the cosine means this D1 is that means the selected document will be D1, and we will try to find the cosine similarity between D1 with other document. Okay. So yeah. So here this this part is already there, right? Sim of D1 comma Q means D2 with query, D3 with query, D4 with query, and D5 with query. This similarity score is already there. Next part was to, since we have already picked the highest score that is a D1. Then we will try to find the similarity score between D1 with other document. So D1 with D2, the similarity score is 0.85. D1 with D3, the similarity score is 0.4. D1 with D4, this one, D1 with D5. Okay. Now MMR score we will calculate. Okay. So MMR score will be, so we just need to put this thing into this formula. Okay. So here if you see the score, 0.389, 0.44, 0.42 and 0.415. Okay. Now, which document we will pick which has a highest score? So D1 with D3, that having a highest score. The score is 0.44. So so document 3 providing the highest score. So now initially we pick the first document that is having a highest similarity score. Then in the next case, we have added D1 with D3. So now third document if we need to pick, again we have to follow the same process. Okay. So D2, D4, D5, these are the document that is remaining. And again, max similarity with D1, comma D3. Okay. So this is how we calculate for miss if you have to find the next document. So D1, D3, D2. In D2 case, the MMR score is highest. Okay. So this is how we, so finally, if we see the document that is selected D1, D3, D2, D4, and earlier the order was, uh, yeah. So earlier the order was D1, D2, D3, D4, D5. Now based on the MMR score, the order gets changed. So now the order is D1, D3, D2, D4 and D5. Okay. So if I put k equal to 3 in MMR, so the document that it will give is a D1, D3, D2. Okay. So this is how this MMR thing works. Any doubt in that? How it is calculating? Okay. Now, okay. Again, come back to formula. Okay.
Sir,
Ha, ha.
sir, do they ask about this algorithm in the interview questions?
No, they means MMR. Uh, they may ask, but it is good to understand how MMR working.
Yes, sir.
Yeah. Now let's say here if I put lambda equal to 0 in this formula, if I put lambda equal to 0, okay, or let's start with some other thing, uh, other value. Let's say lambda equal to 1. So the formula will get change, right? So if I put lambda equal to 1, what will be the formula? So lambda I put 1, so 1 into similarity of di comma q, right? Minus 1 minus 1 into max of sim of di comma ds. Okay. So this value will get 0, right? So the MMR of di will get sim of di comma q. And this is what? This is a nothing but cosine similarity. Cosine similarity. Okay. And so this is when lambda equal to 1. Okay. And when lambda equal to 0, when I put lambda equal to 0, this term get omitted, right? 0 into something will be 0. So only the second term will get remaining. So MMR of DI will be 1 minus 0. That is a 0 means 1 minus lambda. So lambda value is 0. So it is nothing but 1 minus max of sim di comma ds. Okay. So this is when lambda value is 0. Okay. So there are two terms, relevance and redundancy. Okay. So when you put lambda equal to 1, so redundancy can be high. Okay. Because when we put lambda equal to 1, the formula is totally cosine similarity. Okay. And when you put lambda equal to 0, relevant, uh, it reduce redundancy. Okay. To 0. So what we do, generally we put lambda equal to 0.5, or typical value of lambda is generally 0.7. Okay. So it will uh, try to get mix of redundancy and relevance. Okay. Yeah.
Sir, one doubt, sir.
Huh.
Sir, this redundancy and relevance, are they anti-proportional to each other?
Obviously. Redundancy means
And
what? Repetition, right?
repetitiveness.
Huh.
Yes, yes. Okay,
And
sir.
you can you can use some other term if you have any doubt, but the idea is like redundancy means multiple copies.
Yes.
Okay. And relevance, if I using relevance,
Accurate.
basically, so reduce the multiple copies, okay, in the
Yes, sir.
answer. Okay. Yeah.
Uh,
So
and sir, also in that when we put lambda equals to 0 in the formula, the first term is 0. Then it should be like 1 minus. Okay, that is in the bracket. So first term will be omitted, right? When we put lambda equals to 0.
that only I said na, when lambda equal to 0. So this is when lambda equal to 0. So this is 1 into max of di
Yes, yes.
comma ds.
1 into.
We have
Yes,
used
yes,
the
yes.
second term, right? Here
Yes,
we
yes.
have put lambda equal to 0. So 1 into max of that. When put lambda equal to 1, so this term will be there.
Yes, sir.
So when we put lambda equal to 1, so it is all similar to cosine similarity. The MMR formula get changed to cosine similarity. Okay. When we
Yes, sir.
put lambda equal to 0, at that time it totally find the relevant, means okay, means it will try to remove the redundancy.
Yes,
Okay.
sir.
And so the typical value of lambda is 0.5 to 0.7. Okay. So now let's see it through some example. So here if you see also, uh, so without MMR, what is the problem? Okay. First, let's go through this document. So why is MMR important in RAG? So information redundancy. Okay. So LLM receive the same information multiple times. Okay. That is the main thing. And so wasted context window. So because while generating, you are passing that information to LLM. Okay. And in LLM, you are passing the same multiple copies. Okay. Means the same information multiple times you are giving to the LLM. So you are basically wasting the context window. Or let's say in LLM, you are giving the same input twice or thrice, right? Then means what is the use of giving the same copy multiple times to the LLM? Or the let's say if you retrieve any question answer, and in that answer there are as I said, the same MS Dhoni example, the same thing you are giving to the LLM while generating. What is the use of giving the same copy multiple times, right? That is of no use for LLM. You can give only one answer, means only the different answer to the LLM. That will helpful. So that will basically the problem of uh, cosine similarity. And also poor user experience. Let's say if you are creating some, or maybe let's say if you search in Google, okay, and you are getting the same output. Let's say, sorry, you are getting the same output. So you do not like, you want some different variation. Okay. You do not want mm, mm, all the pages. Let's say in the first, if you search something, all the pages should be different. Okay. Because if you ask, let's say Facebook, not every 5 6 things come under Facebook only. Okay. The output could be related to Facebook only, but one page should be Facebook Wikipedia, Facebook website, and other Facebook related thing. But not all Facebook social media link. Okay. Skip. Yeah. So this is the problem with the cosine similarity. With MMR, it cover multiple aspect of a topic. As I said, in a Facebook, if I search, it should give the Facebook Wikipedia page, Facebook link, and Facebook business, all the other variation of Facebook, right? So MMR basically try to help you on that. And the same, the problem with cosine similarity, it will just fulfill that thing if you use MMR. Okay. Uh, Here, if you see L equal lambda equal to 1, as I said, the term you can choose differently. Here, lambda equal to 1, pure relevance, same as cosine similarity. Okay. Lambda equal to 0, pure diversity, maximum difference from selected document. Just give me 1 minute.
you are on mute.
So here different value of lambdas. Okay. And as I said, for lambda equal to 1, specific question need best matches. So if you put lambda equal to 1, it will try to give similar document. When you put lambda equal to let's say 0.5, it will try to give you the variation as well as the relevant answer. Okay, so the default choices will be 0.5. Uh, yeah, so let's say this is the document. If I take some example about renewable energy, okay, and in that we have implemented two things. So one is a cosine similarity, okay, and other is MMR, okay, and we put lambda equal to 0.5 at k value 5. So there are total 15 documents. Okay. So let's say if we ask this question, okay, renewable energy sources and technologies. So first we will see with similarity search with score. Means this is using cosine similarity, right? So here, if you say solar energy technology as advanced, this is the answer. First answer. This is the second answer. Solar power harness energy, hydroelectric power, wind power, sustainable energy. So this is with the help of similarity, cosine similarity. Okay. And this is with the help of MMR. For the same query, MMR giving the output solar energy. Then this the circular economy principle aim to hydroelectric, rainforest, sustainable agriculture. Okay. So if you see the similarity search giving you the document 103212. So this is the ID of the document, but MMR search providing you the document 1143812. Okay. So it providing and the topics that it cover in similarity search, the topic it cover two times solar, then hydro wind conversation. Okay. In MMR, if you see all the topics are different, right? Solar conversation, hydro ecosystem conversation. So it will try to cover the multiple aspect of your question. Okay. So similarity search give four unique topics. MMR search also give. Okay. Sorry. Similarly, this is the second question. What are the environmental impact and effect on ecosystem? Let's first run it. Yeah. So the question that we are asking, what are the environmental impact and effect on ecosystem? Wetland provide biodiversity losses. So these are the five answers from the similarity search. In MMR search, it will be slightly different. Okay, so it will try to capture the variation in the answer. And also you can basically play with the different value of lambda. Okay, so let's say if we put lambda equal to 1. So lambda equal to 1 is pure relevance, lambda equal to 0 is pure diversity. Okay, so in case of MMR, we put lambda equal to 5. So we want diversity as well as relevance as well. Okay,
So in case of lambda equal to 1 is pure relevance. Here we can, in case of lambda equal to 1, it is similar to cosine similarity, and in that we can have a multiple copies. So if you see, when we put lambda equal to 0, sorry 1, solar terms come two times. Okay. And if I pick top three results, so if you see solar power harness energy, solar energy technology, okay. If you put lambda equal to 0.7, high diversity. So if you see here, solar terms come only one. There is a less repetition. Okay. So these are the top three results. And here the same thing that we have seen solar two times. And if we just try to find the similarity score between those two documents. So 0.6449. So there is a 64% similarity in that. Okay. Then similarity with solar with wind 49%. Okay. And if you see also the two solar documents are highly similar to each other. And MMR recognize this and prefer the wind document for diversity, even if the second solar element has slightly higher relevance. Okay. So MMR basically help you to get diversity in the answer, yet maintaining the relevance as well. Relevance means, let's say if user is asking something, whether the answer that with the help of MMR is somewhat similar what user is asking or giving you totally different aspect. So that is why lambda equal to 0.5 we generally fix to get both the things. Okay, diversity as well as the relevance. So when to use MMR? So first is queries broad or exploratory. So for example, tell me about climate change. So in that we want multiple perspective. Okay, and limited retrieval budget. So let's say if you put k equal to 3, okay, retrieval limited retrieval budget because all this retrieval you are passing that to the LLM to generate the final answer. And if you put k equal to 10, so k equal to 10 means you are passing all these 10 into the LLM. So the cost will increase because the number of document get increased, and because of that the number of tokens will increase, input token. Okay. So if you have budget is limited and in that you want a very means you want to cover the answer, means cover different aspect, at the same time you do not want to increase the cost, so MMR will help you in that scenario. Okay. Also, document collection has redundancy. As I said, let's say if you are creating some document, or let's say when you're creating a rack system and you have basically uh, collecting the information about that product or anything from multiple sources, and in multiple sources there may be some overlap. Okay. But but in your answer you do not want that thing, means you do not want the overlap thing, you want multiple perspective. So MMR basically help you when in your document there is a multiple a redundancy is there. Okay. Yeah. So fourth one is a comprehensive coverage is important. Okay. So comprehensive coverage, as I said, when your user is asking a question, you want to give multiple perspective so that user answer can or user query can be answered in a multiple perspective or multiple direction, so that he can have a broader understanding of that question or question that he's asking. Okay. So MMR help you to see the things in from multiple direction and give you the proper answer to the user. Okay. Then uh, when to use a similarity. Okay. So for example, queries is specific and focused. Okay. So what is photosynthesis? So in that you do not want diversity. Okay. So in that scenario, we can use a cosine similarity. Okay. Then large retrieval budget mm, or means large retrieval budget. Generally, company don't have large retrieval budget. So it just means that your company do not worry about or may not be company or it may be the application where the budget is not a constraint. Okay, you are creating a LLM application and budget is not constraint, so you can choose put k equal to 20, let's say. So you can based on user question you can get top 20 documents from the uh, document that you have stored in a vector db. Okay, so it will basically cover all the things. Basically if you using k equal to 20, it means it will try to cover all the variation uh, on that uh, means vector db, that is means all the document uh, related to what user is asking. Okay, so in that case you can choose similarity score, and also you can choose similarity score when document are naturally diverse. Means uh, when you are creating a database, at that time you already taken care that document is not um, document is diverse. Okay, there is a not a redundancy or multiple copy of the same thing. Okay, so at that time you can use a cosine similarity. Then you need all relevant information. So as I said, you just need what user is asking. uh, so you want the answer only related to what user is exactly asking. So you do not worry about how multiple uh, answer may be. You just want that you just give me the answer related to user question. Okay. So similarly here lambda parameter tuning. Um, so lambda equal to 1, as I said, it is similar to similarity search, and lambda equal to 0, pure diversity. Okay. So the answer lies between pure diversity and similarity search. So lambda equal to 0.5 is a balanced approach. Okay. So here computational cost MMR is more expensive than similarity search. So this computational cost is retrieving the document from vector DB, not the cost on LLM. Okay. Yeah. So this is about MMR. Any question in MMR? Okay. So just giving a quick recap of again. So till now we have basically go cover the retrieval part, or so in retrieval part again I'm just asking. So first part is a document preparation. Okay. So document preparation means uh, the steps may be collect document in collect document, and the document can be in PDF, from web pages, it can be images. Okay, so this is the first part. Second part, clean the document. Okay, third part will be load the document. Fourth part will be chunking, breaking the document into smaller parts. Okay, fifth part is embedding. In that, calculate embedding. Yeah, before that, choose the embedding model and calculate the embedding. Okay. Sixth step is store embeddings in a vector database. Okay. So so these steps, all these six steps is generally when you are creating a rack system. So before a user is asking any question, first you need to um, go through all these steps. So the final aim is to store the embedding in a vector DB. Once you create the or save the uh, data in a vector DB, the next step will be, so let's say user is query, no, now user asking something. So in that also the same embedding model as we have used for vector DB, we have to use. Means you cannot choose OpenAI embedding when you are storing that into a vector database and here some other model, Olama embedding. Both the embeddings should be same and also should have the same dimension. Okay. So here you cannot, I mean, it is not like here you choose text embedding small and text embedding large for query. Both the things should be same. Okay. So here embedding calculation. So user is asking, let's say the question. So you need to first calculate the embedding. Then that will, based on that embedding, it will try to find the relevant document. Okay. So let's say user, you have put query, user is asking something and you decided k equal to 5. Okay. K equal to 5. So what it will do, so let's say this is your vector DB. Okay. So it will, so based on user question, it will try to see what are the 5 similar document, and this similar document you can use different algorithm. Either you can use MMR or you can use similarity score. Okay. That is up to you. So based on that formula, if you choose similarity score, it will try to give you the 5 document. It will, if you choose MMR, it will again give you the 5 document based on the MMR algo. Okay. Now, let's say you have asked something and it give you the 5 document D1, D2, D3, D4, D5. Okay. 5 document you give and let's say query. Let's say I'm just to make it simple. What is Newton law? Okay. So this is, let's say, user question. Okay. And D1 to D5, it all have the answer related to Newton law. Okay. So you have query and you in vector DB, you search it and it have provided D1 to D5. Okay. So, so this process to get from Q to D1 to D5 is called retrieval process. Okay. This is a retrieval part only. Retrieval is nothing but just extracting the information from vector DB based on user query. Okay. Now, now you have query and vector DB output you have. Okay. So vector DB output is D1, D2, D3, D4, D5. Okay. So you have query and vector DB output. Now, here till now LLM not come into picture. So here you have used embedding and storing into a vector DB. And this part I said, this part is called retrieval. Till now what we have seen, that is a retrieval. Now what you do, you choose one LLM model and you are passing this query and D1 to D5 to the LLM. Then LLM basically uh, huh. So LLM is like brain. Okay. LLM is like brain. So user has asked what is Newton law and your vector DB provided the pages. Okay. For example, in D1, D2, D3, D4, D5. Okay. He said that, okay, these are the pages where Newton law answer is there. Okay. Now LLM will see what user is asking and what vector DB has provided. Okay. And so basically we are just adding this to information and passing to the LLM, and then LLM can generate some answer based based on what user is asking and the information D1, D2, D3, D4, D5. So all this D1 to D5, it is like plus. Okay. So let's say in D1 there are 100 tokens. In D2 also let's say there are 100 tokens. So total you have 500 tokens, and let's say in query there are 10 tokens. Okay, so total tokens that we are giving to the LLM 510. Apart from that, we can also give some system instruction that is optional. So since system instruction key, we can define the role of the LLM. Okay, so that also we are passing. Let's say system instruction we are giving. You are an helpful assistant which give answer related to science only. Okay. Now, so this is 10 token and I'm assuming each document will have 100 token per document. Okay. Just so total have 510, and let's say system instruction is around 30 token. So how many tokens are there? 540. Okay. 540. And in output, it can say, let's say one more parameter. Okay, just I want you to answer how to control the number of tokens, or what is the parameter name by which we can control the number of tokens that LLM generate. Anyone?
Sir, temperature. No, no, not temperature. Context.
Max token. Have you heard max tokens? Max token. So max token, let's say if you put 200, so the output that LLM generate, its size will not be more than 200 token. Okay. So if user is asking what is Newton law, so it will say, okay, Newton law is blah blah, and this output will be, if you calculate the number of tokens of this output, will be less than 200 because we put max token equal to 200. So this parameter you can fix. This is up to you. Okay. In LangChain, you can fix this parameter. Yeah. Now again, my objective was, let's say here, if you put k equal to 5, right? In this case, if you see what user have asked, you what is Newton laws and how many tokens, input token, how many use? If I calculate the number of input token is 540. Output token is, let's say if you fix 200. So if you fix 200, the output will be less than or equal to 200, not more than that. Okay, so for example, what is Newton law? It may give, let's say 150 token. Okay, so this part, the final output that LLM is giving, that part is called generation. Generation. Okay, and this addition. Okay, so before that, what we have seen, vector DB was giving, that part was retrieval. Then adding this retrieval part with question and system instruction, that part is called augmentation. Okay, and the LLM output that it is giving, that part is called generation. Okay, so now again the name is retrieval augmentation generation. So augmentation is nothing but addition of what? Addition of vector db output plus query plus system instruction. And system instruction is optional. Okay, so augmentation is addition of vector db output plus query plus system instruction. Okay, retrieval part is, in retrieval, the document like d1 d2 up to d5. So it is just based on user query vector db output. So that is a retrieval part. But before that, you need to basically calculate the embedding, save it into a vector database, prepare the document. So all this process come under retrieval part. In augmentation part, you just need to add the query plus vector db output, that d1 to d5, and then system instruction. Generation part is LLM output. Okay. So this rack system is, if I again, it is just a combination of embedding model plus vector DB plus LLM. Okay, so if you combine all these things, that is called a rack system. Okay, so that generation is a very small part. Most of the majority of the part is retrieval. Augmentation is also a small part because just you are adding all those things. And you don't have to, means there are already libraries which do all those things in a few line of code, means in LangChain only, that will, even that generation part is also there, that we'll see. But this is how the rack system, this is the complete pipeline, or this is the process to basically create a rack system. Now, any doubt in this? See, in Gen AI, agentic or any AI, the whole, if you have heard about perplexity, how many of you have heard about perplexity?
Yes, sir. It's like Airtel based, like Airtel has introduced it.
Perplexity, this company is the the CEO of Arvind, something Arvind, his name I forget, but title I forget, but his name start from Arvind, and he's a IIT Madras graduate. So currently, this company worth is means around means I need to search, but that worth is very much. Okay, maybe we can search. Okay, perplexity valuation, valuation and honor. US 20 dollar billion, 20 billion dollar. Okay, so is dollar is how much? Around one single dollar is 8,000 CR. Means one single dollar is means currently dollar to rupees price is dollar to rupee 88. Okay, so 90. So 90 $9,000 or 9,000 CR equal to $1 billion. Okay, so it is like 1,80,000 CR. This is the valuation of this perplexity. Okay, and uh, Arvind Srinivas. Okay, this is he is the CEO of this perplexity. Okay, he is also a former employee of OpenAI. Okay, now what perplexity do? So perplexity is a just alternative of a Google search. Okay, but in background, what it use? It use RAG system. RAG system. Now your question can be, this RAG system doesn't look means very complex, and how it it basically beating or the valuation is 20 billion. Okay, so RAG system is just a base. They are trying different things. Okay, to basically get the relevant output. Even if I show you, so Airtel user, they for them the perplexity providing a free or mm, perplexity providing 1 year search. It is similar to chat gpt, but like Google also sorry, OpenAI also releases one web search, right? Google OpenAI Atlas. Okay, recently OpenAI Atlas, chat gpt Atlas. Okay, so this is also a web browser, and mm, I don't I I don't know whether you have heard or not. Because of this OpenAI Atlas, Google losses uh, OpenAI Atlas, Google valuation loss. Just see. 100 billion in a market value after ChatGPT release Atlas. Okay, so ChatGPT Atlas. So this is also similar. This is also using a rack system. Okay, all this perplexity, ChatGPT, Atlas, even Google is also using a rack system. The difference is that they do not tell how they are fine tuning, what are the parameters that they are playing with, and also they are adding some extra things. Okay, but the base is RAG. Okay, and you can imagine because ChatGPT LLM model performance is very high and its embedding model is also good. Because of that only Google loses 100 billion in a market value. And when the news just 6 days before, if you see, this is the even some companies or some papers saying 150 billion. You can imagine 20 billion is around that much. So 150 billion you can imagine. So that is the power of rack system. And currently there are different variation of rack that we will see. But just all this news or all these things, basically I'm telling just to showcase what is the importance of this rack. Okay, that we have learned. So in that also in next classes we will see how to evaluate the rack, evaluation of rack system. Okay, so evaluation in the sense how accurate your rack system, whether it giving you the right answer or not. So how to evaluate that thing, that is also very important. In interview they will ask how you have evaluated that your rack system, whether it is working fine or not. Okay, and there are different variation of this, like in RAG also there is a agentic RAG, corrective RAG, and there are other variation, but this we'll see when we learn a agentic AI. Okay, so just I want you people to go through some document of RAG, and if you face any doubt just let me know, but try to see how all these RAG things work. Yes. Do not worry about the code because code can be 4 5 line of 4 5 line of code give you the complete RAG system, but that will not help you to understand the topic. And you cannot play with the parameter unless you know how because how the effect of those parameter will change on the output and um, price, all these things. Unless you know how this parameter affect the rack system, 4 5 line of knowing the code is not of much use unless you know the how it is working. Okay, so the working is very important. Code you can do, means right now there are enough tools. You don't have to learn all these things, you just write one thing and it will give you the code and you can run. And if you get the error also, again if you paste it there it will provide you the out, but understanding will not be there. Okay, so understanding is super important. An interview nobody will ask about the code of rack system, even a single line of code they will not ask, because they also know in Python they will ask what is class or what is list tuple, all these things there they will ask you to write a code, but in LangChain or rack system they will not ask you to write a code for that. Okay, so do not worry about the code, just focus on the how the things are working behind that code. That is super important. Okay, uh, again I am repeating, so please choose the uh, anyone chooses the means uh, what do I call a domain for project that you people want to do. Adit, have you chosen the domain?
Yes, sir.
Uh, so which domain you have chosen?
Sir, I am thinking to build a chatbot using rack system on psychology.
Psychology. Okay, good,
Yes.
good.
In psychology, sir, child psychology. For
Okay.
example, there are certain kids who are not open to everyone, so they may
Mhm.
find it easy and comfortable to open to a chatbot.
Okay. So then start collecting documents. Document in the
Yes,
sense, you know na what I'm telling about document. So document
yes,
is
yes,
nothing PDF or website link. Just collect,
yes,
create an Excel sheet or a folder where you have a list of PDF. It can be in docx, any format. Okay. Just collect
yes,
the
sir.
sources.
Yes,
So once you have a good number of sources,
Ah,
then
yeah.
that will be better. Okay.
yes, sir.
Yeah. Okay. Raghava.
Sir, I want to do on like I have decided like I have already kept the project, so I want to do on it only. So I want to do on legal system.
Legal system. Okay.
Yeah.
So currently means you already started or started going to company.
Yeah, company, but project didn't start. We are just in. We are like we are a team. We
Haha.
said that we have to create POCs and we have to pitch in the market for free services. So the project didn't start yet. So
Okay.
meanwhile, I want to just know step by step in detail, like from scratch. So
Okay.
like so that it will be helpful for me in that real time
So
project also.
so that will be means in Deloitte most the chances are that they are related to financial legal system, right?
So taxation and finance and everything.
Okay. So just try to means which legal system you want to work on.
Like I want to search on it, like whatever legal system, like any like our penal code like that, because I have already kept the process, so I want to get more detail about it and do
Okay.
hands-on on it like that.
Okay. 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 Good. Yeah. Anyone else selected? Means
Sir,
some.
hello. So, sir, actually, before the course, I was planning something related to a hyper-personalized human teacher chatbot. So basically,
Your
like
voice is
which
not clear.
students who can use the mobile phone. Hello, can you hear me,
Haha.
sir?
Yeah. Yeah.
Yes. So basically, I was thinking about, I not thinking, but actually, I have planned something, and I have already made something on that.
Okay.
It is a hyper personalized human teacher chatbot. So it will be available for all the students who used to, like, and who can use smart devices, and it will be basically like a complete a teacher, just like we get a personal teacher as a tuition teacher, and like just like you are teaching in the course and all the things. So it will analyze the pattern for the student, that what are the things they are missing, and if a student want to learn something, then what kind of things he should learn first, and then he can grab on that particular part. So it will work on that basis, and there are more things that we can provide the quizzes as well, that for a particular chapter and subject. So suppose if a student want to learn probability, and then how he can start. So before probability he should know the other things, and if he passes those quizzes, then he can learn probability, and it will provide the information to the student. Then from this process, it will provide the step by step, it will provide the quizzes at a time, and it will also help the students that you should follow this path one step by step. So I was thinking on that part, and it will also help the organizations and schools and colleges. I have made a UI as well on that one.
Okay.
Actually, it
Nice.
is not live yet. I'm still working on it. It was my idea before the course, so
Okay.
I will work on that part.
So it is a generalized thing or how it is? Means it is a focus on one subject at it means or
No, no, no,
it
no.
is
It
like
will
a
be
generalized
relate.
subject.
It so firstly, currently, I'm now focusing on only mathematics,
Okay.
and then I'll be putting all the subjects once, because I will be collecting all the data like papers and books. I will I will upload all the things one by one. As I am starting, so I cannot do all the things at a time. But
So you all
slowly, I
so you already created a rack system for that?
No, not rack system, but a simple UI. I will share you someday, sir. That
Okay, okay,
how it can help the students, and then how it can help the teachers to make the students progress better.
sure. Okay.
Yes, sir.
Yogesh,
Yeah,
uh-huh.
I
What
have
you have
chosen
selected?
for SBI Bank. I have chosen that.
Okay, SBI
Mm,
Bank.
yeah.
So collect na all the links. Links in the sense, just go to SBI website. Let's say
Okay.
credit card or all this thing. Just
Mm-hmm.
copy the link that coming in like www or HTML page link and
Okay.
save it in a Excel file. Okay.
Okay. Okay.
Just start collecting all those things in a
Okay.
Excel file. Okay.
Okay.
Because
Okay.
for each tab there will be a different link. Just copy
Mhm.
the link and save it into a some Excel file
Okay.
along with the information what this link represent. So make two column. One column is a link name and other
Mm,
column name is a description of that link.
okay.
Okay. For example, if you choose a SBI Platinum card, okay,
Okay.
just in description, write, okay, this link is about SBI Platinum card, credit
Mhm.
card. Okay.
Okay.
Short description, not a long description. Just
Mhm.
put that. Okay. Yeah. Good. Chirantan,
Sir, I also build a finance chatbot.
finance chatbot.
Yes, sir.
So finance is
Specific
a very broad.
spe means I think a specific bank or multiple bank.
Okay, I have one suggestion for you.
Uh,
In finance, you have a in finance you have a Chirantan, can you tell him to mute? Okay.
sorry, sir.
uh, So what you can do, there are multiple credit card, right?
Sir, I go bank's website and bank's website means I go bank's website sitemap. Here many links available.
No, just I'm telling you, there are multiple credit card, right?
Yes, yes,
So let's say SBI credit card, and many times some offers is coming. Okay, and we don't know which credit card to choose,
yes,
right? Because every card has a different advantage, disadvantage, eligibility as well,
yes.
right? To get also. So just collect famous credit card information. Okay, their links. Okay, then we will create a chatbot. Let's say if I have to go for shopping, okay, if I have to create some, uh, let's say if I have to do traveling, then I know which credit card to choose for traveling. What are the advantage of using those credit card? How many points I can get? So,
Okay.
so this will be, I think, I haven't seen any such product, okay, in the market. So this will basically help you to build a chatbot, which basically help you to create a uh, user. Let's say if they want, if there is a some rich person who has good account balance, all those things, and fulfill the criteria, and let's say he want to select some credit card, he don't know what are the advantages, disadvantage, so he can come to your chatbot and just ask, okay, for traveling which credit card is best, okay, which credit card can provide me the maximum benefit. So just collect the all credit card
Credit card data.
information. Huh.
Okay, sir. Thank.
Okay. Yeah. Okay, guys. Thanks everyone. That's it for today's class. Next
Sir,
class.
and collect in a Excel site. Excel sheet.
Huh.
Okay, okay, sir.
Okay. Huh. Okay. Thanks everyone.
Thanks, sir.